Do you also post like your work, the work examples?
Since I recorded, I don't, because I hope that he could just go through and watch it and find the answers. However, these examples are the examples that are in your textbook. So they are worked out there too. So they're the same number examples, like example 1, example 2, stuff like that. So
Somehow I got it like a dirty ripped up book. Like,
luck of the draw.
I didn't even realize it until after I had it that it was like.
Weird.
Yeah.
You get what you get, right?
Yeah. They don't really look through whenever they give them to you, or when you buy it. Like,
When they buy them back, maybe you can sell it back. And
I'm gonna say
yeah.
that is my plan.
All right. So on Friday we went over the normal distribution curve and the Z data. We didn't really get to a lot of the application. We did the example, if I give you 2 Z values, find the area between. We're going to finish the last 2 examples on the PowerPoint, and then I want to go to the questions in the that are assigned, either they're assigned or just ones kind of like it. Because sometimes they'll give you the Z value and you don't have to do much. Sometimes they'll give you the data point and the information about the data point, like the standard deviation and the mean. You have to calculate the Z value by yourself, then look at the table, find the area, and then extrapolate how many data points were in that group. So if it was 50 data points and you find an area that's 75%, take 75% of 50 and that would be your answer. So some of the answers in the back, you might not know exactly how far to go, because you have to be careful to read the question, what it's asking. If it's just asking for the Z value, you just look at the Z value. You find that. If it's asking for a % of the data between a certain range, if they give you the Z values of that range, you're one step closer to finding that. But if they give you the data points, then you have to find the Z values, and then you have to go from there. So we'll do some various examples of how to present that. Calculating the Z-score. You can always find the data value minus the mean divided by the standard deviation. That will always give you the Z-score. It's positive, it's above the mean. If it's negative, it's below the mean. But on our table, all of our Z values will always be positive. Because area, it doesn't, since it's symmetric about the origin, symmetric about the mean, the Z value to the right and the Z value to the left is going to have the same area. So instead of making that table twice as large, they only publish the positive Z values. The negative part comes in important when you're looking for area between 2 ranges, because if one's positive and one's negative, you're going to add the areas. If they're both positive or both negative, you're going to subtract the areas. And then the last thing we're going to look at is the area above and the area below. So the area to the right and the area to the left. And that's important if it's positive or negative. So we did some examples. We looked at some of the tables. I think drawing pictures are very beneficial because you can see if you're going to add or subtract areas. And the last one we did was a positive and a negative Z value. So if you were not in class on Friday, which like maybe a third of you were not in class, watch that video and get kind of caught up on what this is. You might be a little lost at this point. So the last thing that we had here is to the right or to the left. Both of these are to the right, but we could do the same thing to the left. Find the area of the standard normal distribution given a Z-score of 1.7. So if I was to draw this, my pen doesn't want to draw.
Are we out of batteries?
I don't know. I don't think my battery's connecting. Okay, so if I was to draw this picture and I was to put a Z-score of 1.7, so this would be the mean A z-score of 1.7 would be here. If I look in the back of the book, the table gives me the area of this shaded region, right? I want to know the area to the right. So I really want to know this area. What do I know about the red plus the green? If it equals 0.5, equals half, because half of the population is to the left of the mean and half of it's to the right of the mean. So this area over here is 0.5, and this area, all of this area together is 0.5 for an area of 1. So I know the red plus the green here is 0.5. So if I look at the table, the corresponding area to z-score of 1.7 is what? So I'm going to go ahead and pass out this pretest. We're not going to get to it today, but at the end of the pretest, it has that table. This is the same table you'll have on your exam. So not all of you guys have your textbooks here, so you don't have that table in front of you. So I'm going to go ahead and give you this pretest. It will be posted online as well.
Good job.
So if you look at the very last page, you see that table that's in your appendix. A common mistake here and looking at this table is students will look under the A when they're, so be really careful that you follow the Z down. So we want 1.7. So if we find a Z corresponding to 1.7, we have a area that corresponds to 0.455. Do you guys see that?
I don't see 1.7.
It's on this table.
Oh, I know.
So it's in the very right column, in the very top right column. Okay, so did everyone find the corresponding area? 1.7 is 0.455. So that tells us the red shaded area is 0.455. So what would be the green shaded area? So to find the green, I would take 0.5 minus 0.455. We get 0.045. So drawing the picture shows us that 4.5% of the data points fall above 1.7. So you would say 4.5% of the population of this data would be, if it was height, taller than a corresponding z-score of 1.7. Some of these will say, you weigh 245 pounds. Find out what percent of the population is heavier than you are. You have to go find the corresponding z-score for that weight. Then once you have that, you plug it into something like this, and then they say, 4,000 people live in your town, and then you could plug that in to 4.5% of 4,000, and you would get how many people you would expect to be heavier than you are. So sometimes some of these are multi-steps, and you get close, but you don't actually answer the answer. So we're going to do some examples of answering the answer here. This is how you apply it. If I give you a z-score, or you find a z-score, and you want to find the population that's larger or to the right, you're going to take 0.5 minus your z-score. Unless your z-score was negative, you're going to take 0.5 plus it. right? So that's why sometimes drawing it on this curve, it can be really beneficial, because if I'm looking to the right, I'm going to take 0.5 plus my area that corresponds to my z-score. So let's look at B. See, B is negative. I'm still looking for the area to the right. I know this to be 0.5. I look at the corresponding area for a z-score of 0.95. 0.24. I get 0.32.
0.329.
So if we go to, are you looking at the area of 95?
0.95 is 0.329.
So yeah, you want to look at the z, find the corresponding z of 0.95, which would be 0.329.
Mhm.
So that would be this shaded area here. And if I want to know the data points to the right of it, I would have this area plus 0.5. So you can't always say, oh, if I'm looking to the right, I take 0.5 minus the area, because it depends on if your z-score is positive, if your z-score is negative. The same thing with the area to the left. Question.
So the 0.5 is the area to the right.
The 0.5 is the area to the right of the mean.
Okay. And then the 0.95 is the z-score.
This is the z-score.
And then so if we add the 0.329 and the 0.5, we get the area to the right
Of the z-score of negative 0.95.
Okay.
If I wanted to know the area to the right of a z-score of 0.95,
It'd be,
I would be 0.5 minus 0.329.
wait a minute, what?
If I wanted to know this area,
Uh-huh.
it's going to be 0.5 minus 0.329. Because this area is equal, this is a symmetric curve.
Yeah.
So if I go 0.95 to the left and 0.95 to the right, those areas are equal to each other.
Okay.
So it just depends on if you want the area to the right or the area to, or the area to the right or area to the left. If your z-score is positive, if your z-score is negative, you're going to add 0.5 to one of them, and you're going to take 0.5 minus the area to the other one.
Since Friday, but what does that tell us now?
This tells us what percent of the population would the data points fall to the right of this data point. So this data point would correspond to, say, a height or a weight.
Okay.
And the z-score is how we normalize it to find the area looking at the table.
So would they ever give us the A and ask for the Z?
I've seen it done before. In this book, I do not think so.
Okay.
The Missouri State version of the book, I think it does ask that for possibility if, find the corresponding z-score that
Mhm.
gives you a certain area. But again, that's just reading backwards
Okay.
on the
Yeah.
table. I don't think this book does. The last example is to the left. The exact same application, so being able to visualize it really helps. So the z-score of minus 2.2, and if I want to know the area to the left, I look up what is the area that corresponds to 2.2 of z value of 2.2. That A would be what?
0.2 is 0.486.
Everybody agree?
Mhm.
So here is just the application of how would I find the area to the left of a z value of minus 2.2. What would I do?
Take 0.5 minus that.
Yep. I would take 0.5 minus 0.5 minus 0.486. If I was to answer B here and I have a z-score of 1.95 and I want to know the area to the left of that, I'm going to find the area and I'm going to add 0.5, right? So what is the corresponding area to 1.95?
0.474.
0.474. And I'm going to take 0.474 plus 0.5. So you see how drawing the picture kind of helps visualize if you're going to add or subtract.
So if you go to the right, you add.
No, don't think that way, because it depends if I'm on the left side of the median or the right side of the mean. Mean, median, mode, and standard deviation are all the same. This is the middle.
Okay.
Half the data is to the left and half of it's to the right. So if I'm on this side of it, like I am over here, and I want to know the area to the left, I'm going to take 0.5 minus my corresponding A to the given Z. Here, if I'm to the right of it, I'm going to take 0.5 plus the area that corresponds to the given Z. But if I just change the word left to right, it's going to switch it. So instead of trying to memorize, if I go to left, I'm going to add. Don't do that. Draw a picture and see what am I going to do. Is it 0.5 minus the area, or is it the area plus 0.5? And just to kind of review, we talked about in between two data points. You either add them or subtract them, depending on if they're both of the same side or they're on opposite sides. So that's the only application. Not the only. There's one more application where they could say outside the range, where you take 1 minus your answer of inside the range. And I don't know if that comes up in this class.
Did you give the answers for the last one that we just did?
I don't think I showed it. I just
Okay.
said the math that you would do. It would be
2974. Okay.
Yeah. So let's look at the application here. In your homework, this is 11.6? No, 12.6. So we do 7 through 27. I'm going to do the evens. Are the evens? Oh, I have the answers for all of them. So let's look at number 12. So we're looking at, see, number 12. We want to know the approximate number of data values that will fall within a given range. So if I draw this picture here, I can either kind of do one of two things. I can normalize it and find the corresponding z-scores and look at the table, or I can say maybe if it falls in 1 standard deviation, 2 standard deviations, or 3 standard deviations, I can use the empirical rule. If it falls within 1 standard deviation, I know 68% of the data falls with that in that range. If it's 2 standard deviations, 95% of the data, and if it's exactly 3, 99.7% of the data. So let's see if this ends up following empirical rule. So here I have 100 is the mean. So that's X bar. That would correspond to a 0 Z value. The standard deviation is 8. So if I add 8, I would go to 108. And if I add 8 again, I go to 116. If I subtract 8, I would go to 92. And if I subtract 8 again, I go to 84. Right?
Yeah.
So this would be a z-score of -1, -2, a z-score of 1, and a z-score of 2. You guys see that? I'm going to go ahead and see if I can put this down on this line here. -2, -1, 1, 2. I want to know what percent of my data falls within this range, right? I know by the empirical score that percent is 95% of my data. I could look at my z table and look at a z value of -2 and a z value of 2. They're going to be the same. They're symmetric. So if I go to my table, and I would add them together because they're on opposite sides. So -2 z value would give, or 2 z value would give me 0.477. So if I add that together, what do I get?
.954.
0.954. 0.954, which is very close to 95%. So if I have an N value of 200, what's 95% of 200? 190. So the answer in the back should be 190 for this one. On number 12, do you have the, Ethan?
Oh, number 12. I'm looking at that.
Yeah. So I see if I can pull up the answers here, since we're doing the evens. But the approach to number 11 and number 13 are going to be the same. It doesn't matter if you do the empirical rule or if you use the table. If I use the empirical, I can only use the empirical rule if it's 1, 2, or 3 standard deviations. And on these, I think they all end up being 1, 2, or 3 standard deviations. Exactly.
If they were just to give you a random range and it wasn't a standard
Mhm.
deviation, it wasn't on one of the standard deviations, would you just fill it out and say, like, you would do the area value and then you times it by 100 to get the percentage?
Yeah. So yeah, we'll do an example of one where it doesn't fall exactly on 1, 2, or 3 standard deviation. But on 11 through 15 here, it finds out your ranges fall within exactly 1, 2, or 3 standard deviations. So you can use the empirical rule and just know 68% of the data, 95% of the data, or 99.7% of the data fall within those 3 ranges. Or you can apply the table. There's really no need to here though, but you could say, okay, 0.954% of the data, take that times 200 and get the same answer. And it's an approximate. The empirical rule is an approximate, so you could be a couple off. And look, based on your work, I'm going to look at that. So let's look at the next set of them. Here, it just asks for the data given the z value. They give you the z value and ask to find the corresponding area. So between 0 and 1.95. So if I was to graph that, just visualize it, 0 and 1.95, I'm looking for this shaded region. So I look at z equaling 1.95, what would be the corresponding area? 0.474. So do I need to do anything to find the shaded region? It's the definition of the table. The definition of the table gives you 0 to z, right? The same thing with 18, 19, and 20. Keep in mind, your area is never negative. So let's look at number 20. I have this curve, and I have this as 0, and I'm looking at minus 2.05, and I want to know the area between 0 and minus 2.05. What would be the corresponding area? 0.480. Does everyone agree with that? Table, you look at the z corresponding to that. Now this might get where I give you how tall someone is. Like if you look at the number 15, this is a good example on your pretest. The average hourly wage of an employee is given in the standard, you're assuming it's standard normal distribution and the standard deviation is given. Find the probability a randomly selected employee learns less than 751. So you have to find that corresponding z value, and then you're looking at the data to the left of that. Versus the z value given, there's a little disconnect when, because your book just hits this hard with the z-values and then gives you if I give you an actually application of it, sometimes students don't know what to do with the numbers to get it to the z-value. But once you have that z-value, you just look at your table. And we'll do 15. I don't think there's any examples as far as what I assigned, like number 15. But this is just to give you practice if you know how to apply it to the table. Does anyone have any questions on in between or to the right or to the left?
So it says 1.0 to the right,
Mm-hmm.
and that would be 0.341. You just subtract that from 0.5, wouldn't you?
To the right. So if I was to look at what this curve would look like, if I'm here and I'm at 1, and I want to know data to the right of that, I would take 0.5 minus my area.
Okay.
Be very careful because the empirical rule does not work to the right and to the left, because what the empirical rule is in between standard deviation. So you're missing the ends of it. So sometimes students will say, oh, I know 68% of the data is to the left or in between one standard deviation. So if I want to know to the right, and they make the wrong assumptions there with the empirical rule. The empirical rule only works when you're in between one standard deviation, 2 standard deviations, or 3 standard deviations. So you miss the little part at the ends. If I say to the left of a z-score of 1, I can't use the empirical rule because this is really only a standard deviation of -1 to 1. You can extrapolate it if you know this has to be 0.5, you know this, and then you can take 1 minus this whole area. So there's more than one way to approach it that could be correct, but just be careful you're not making the wrong assumptions using the empirical rule with to the right or to the left data. See if I can find one that's like. Let's look at this College Board number 39. I didn't assign this one, but I think, so we're looking at SAT scores in early 2000, and they were normally distributed, and the mean was 1026 with a standard deviation of 210. What percent of the students scored over 606? So if I were to look at this curve, right, the mean would be 1026, and I would say that would correspond to a z-score of 0. What percent of the students scored over 606? So 606 is to the left of the mean because it's smaller, and I'm looking for the area to the right of that because I want to know who did better, right? Standard deviation of 210. So I could write 1 standard deviation, 2 standard deviations, and 3 standard deviations, but that would be an empirical rule, and that wouldn't get me anywhere because I'm not looking between 1 standard, 2 standard, and 3 standard deviation. So I need to find what's the corresponding z-score. Z would be 606 minus 1026 over 210, which would be negative, what is that? 606 minus 1026? Negative 420 divided by 210? Negative 2. So this would be a z-score of -2. Right? So if I look at the area here, corresponds to a z-score of -2. The minus just means it's to the left. So this would be 0.477. And this would be 0.5. 0.977. Right? And we had the empirical rule said 95% of our data falls between -2 and +2. That would just be this though. You would be missing this green bit here. So that's where the 0.977 comes from. So 97.7% of the students that took the ACT did better than a 606. So do you see how the data can be translated to a z-score, which then can be looked from the graph to find the area to the right of that or to the left of that? So that's probably the common mistake on that one. Students get disconnected once I give you numbers and not give you z values. They don't know how to get to the z value to be able to look on the table. I'm going to let you guys look at it since I don't want to give it too much away because the pretest is, are you kind of ready for it? We have time on Wednesday I'll answer any questions. If you don't have time to get to it before Wednesday, that's fine. We have plenty of time in class. You can almost put yourself in the test-like setting and say, could you do this? No notes, no extra help. Can you do this? Or you might kind of star the ones you want to ask me questions on for sure. And then Friday, we're not going to have class. So again, I might give you online or in your book, there is an end of chapter review. Now, we didn't do all the sections in chapter 12, so be a little careful when you kind of look at it. But they have this review, and anything in this kind of could be free game for the test. So you can also look at that. This is just kind of a screenshot of end of chapter 12 review. It goes over what was covered in every section, and then it gives sample questions from each section. So 12.1, these could be the sample-like questions I ask you. And if you notice, they're very kind of similar to these questions. And your test is next Wednesday, yeah, a week from Wednesday. So I think we have plenty of time to kind of review. And then also, you guys have your homework that will be due on Monday. And so Wednesday, I can answer any questions that you haven't got to on your homework if they haven't matched the answers in the back of the book or you're struggling on that. Because the homework type questions are free game for the exam as well. But again, you only have 50 minutes to take the exam, so this packet is larger than an exam would be. These are just sample type questions to give you guys something to practice. Any questions? The material, there's no new material as far as lecture. It will just kind of all be review and support you guys in what you feel like you need to look at again. All right, I will see you guys on Wednesday.
No one uses this classroom for another 20 minutes, right?
Yes.
Okay.
Correct.